story of the computer is a story of incredible progress, from room-sized behemoths to devices in our pockets. In just a few decades, computers have revolutionized our world. They have reshaped how we work, communicate, and think. Before the 1940s, computers as we know them didn't exist. The word computer referred to people who performed calculations by hand. These human computers were essential for tasks like navigation, engineering, and scientific research. But their work was slow and prone to errors. The need for faster, more accurate calculations was clear. The world awaited a revolution. The first steps towards electronic computers were taken in the 1930s and 1940s. Inventors and engineers began experimenting with new technologies. These pioneers paved the way for the first generation of computers. These early machines were primitive by today's standards, but they represented a monumental leap forward in our ability to process information. The invention of the computer marked the dawn of a new era. It was the start of a technological revolution that continues to shape our world today. The first generation of computers emerged in the 1940s. These machines were colossal and complex. They relied on thousands of vacuum tubes. One of the most iconic was the ENIAC. Completed in 1945, it was a marvel of engineering. It weighed over 30 tons. ENIAC could perform calculations thousands of times faster than humans. This speed was crucial for calculating artillery firing tables during World War II. Despite its limitations, ENIAC demonstrated the potential of electronic computing. The second generation of computers arrived in the late 1950s, ushering in a new era of computing power and accessibility. The key innovation was the transistor, a tiny semiconductor device that could amplify or switch electronic signals. Transistors were far superior to vacuum tubes in almost every way. They were smaller, faster, more reliable, and generated far less heat. The impact of the transistor on computing was profound. Computers became smaller, more powerful, and more affordable. This led to the development of the first commercial computers, which were used by businesses, universities, and government agencies. Programming languages also advanced during this period. High-level languages like Fortran and COBOL made it easier for programmers to write instructions for computers. This paved the way for more complex and sophisticated software. The second generation of computers marked a significant step towards making computing technology more practical and accessible. The transistor, a tiny but mighty invention, had revolutionized the field and set the stage for even more dramatic advancements. The microchip revolution, computing for everyone. The third generation of computers witnessed a revolution in miniaturization and affordability. This era was defined by the integrated circuit, also known as the microchip. Invented in the late 1950s, the IC combined multiple transistors and other electronic components onto a single silicon chip. This innovation led to a dramatic reduction in the size and cost of computers. Suddenly, computers were no longer confined to large institutions. They became accessible to smaller businesses, research labs, and even individuals. The development of the microprocessor in the early 1970s further fueled the computer revolution. A microprocessor is a complete central processing unit on a single chip. This breakthrough paved the way for the creation of personal computers. The first PCs, like the Altair 8800 and the Apple II, were primitive by today's standards, but they were affordable and user-friendly, sparking a revolution in personal computing. The world was about to change forever. The age of intelligence, from PCs to AI. The fourth generation of computers, spanning from the 1970s to the present, witnessed the rise of the personal computer and the internet. This era saw an explosion in computing power, software development, and connectivity. Computers became ubiquitous, transforming every aspect of our lives. One of the most significant developments of this era was the graphical user interface, which made computers much easier to use. Operating systems like Microsoft Windows and Apple's macOS brought user-friendly interfaces to the masses. The mouse became a standard input device, making it easier to navigate the digital world. The internet, born in the 1960s but flourishing in the 1990s, connected computers worldwide. This interconnectedness created opportunities for communication, collaboration, and information sharing on an unprecedented scale. The fourth generation also witnessed the rise of artificial intelligence. AI researchers developed algorithms that allowed computers to learn from data, recognize patterns, and make decisions. This led to breakthroughs in areas like natural language processing, image recognition, and robotics. The quantum leap, the future of computing. As we stand on the cusp of the 6th generation of computers, the future of computing appears more exciting and potentially transformative than ever before. Quantum computing is one of the most promising and potentially disruptive technologies. Quantum computers utilize qubits, leveraging quantum mechanics to exist in a superposition. This allows quantum computers to perform computations exponentially faster. Neuromorphic computing mimics the human brain, excelling at processing sensory data. This technology holds immense potential for robotics, pattern recognition, and AI. Quantum computing, neuromorphic computing, and advanced AI algorithms could revolutionize fields like medicine and energy production.
Please subscribe Girum Computer Experience Share Center YouTube channel for more technology tips.